Okay, so the next question that we have here is question number 15, which is basically the question is, let me erase this and we will do this again. It says that the perpendicular from the origin to a line meets it at the point negative 2, 9, meaning that you have basically you have the point negative 2, 9, so 1, 2, 3, 4, 5, 6, 7, 8, and 9, for example. So negative 2, 9 is this point over here, and there is a perpendicular from the origin that meets the line at this point, meaning that the line is then perpendicular to this line segment, and this is basically the line that we are trying to find the equation of. So for example, you can call it L. This point over here is negative 2, 9, and of course you want to find the equation of this line L. Now over here the problem is that in the previous video we talked about this situation and how you could find the equation of a line based on basically the length of this perpendicular from the origin, and based on this angle over here, omega. So if you have P and omega, then you can go over here and write the equation of the line as x times cos omega plus y times sine omega is equal to P, and that is the equation of the line. Now here in this situation, the problem is that I don't know what omega is, and I don't know what this length is, so somehow I need to calculate it. So I tried to solve this equation in many different ways, but I think the way that we can solve this problem, you want to somehow basically to find the equation of this line. What you need is basically a point on the line, because you basically ultimately if you can use the equation x minus x1 is equal to m times y minus y1. Now if you know the slope of the line, which you could find based on the slope of this line, if you knew the slope of this line, which you could find based on the slope of this line, and if you knew one point on the line, for example x1 comma y1, then you could find the equation of this line L. So now the point is already has already been given to us. So it's negative 2, 9. There is no problem with that. The only problem that we have is that we do not know this angle omega, and therefore we don't know the slope of this line, and therefore we don't know the slope of this line. So now in order to find omega, what you can do is that basically you see over here, if I draw a triangle based on this triangle over here, I can draw a triangle over here. So in this triangle, this length is basically 9 units, and this length is 2 units. And if I take this angle as theta, of course I could find for example tan of theta as, for example, 9 divided by 2 in this triangle. So tan of theta would be equal to, for example, 9 divided by 2. But now if you have some relationship between tan of theta and tan of, and as you can see, this angle over here, omega, is equal to 180 minus theta. 180 minus theta. So what I can do is that if I can find some relationship between tan of 180 minus theta and tan of theta, then I could somehow find out what this angle is, and then I would be able to find the slope of this line. So then what I can do is that if I write tan of 180 minus theta, so you know that basically tan of alpha minus beta is equal to, of course there are other ways to solve this problem, probably easier, but let's try this one. So you have tan of alpha minus tan of beta, 1 plus tan alpha, tan beta. So you can use the same formula here, and tan of 180 degrees minus theta, you can write it as tan of 180 degrees minus tan of theta, minus tan of theta, minus tan of theta, 1 plus tan 180 degrees tan of theta. So now tan of 180 degrees, tan of 180 degrees is the same thing as basically sine 180 degrees, sine 180 degrees by cos 180 degrees. And sine 180 degrees, as you know, is equal to 0, so this whole thing is equal to 0. So over here I will get, basically this becomes 0 and this also becomes 0. So I'll get negative tan theta divided by 1, which is equal to negative tan theta. Negative tan theta. So what that means is that tan of 180 degree minus theta, which is basically this angle, tan of this angle is equal to negative tan of this angle, which means that negative tan of theta. And it does make sense. It does make sense because as you can see, suppose that I had this angle over here. Let's say that I have a unit circle. Let's say that I have a unit circle over here, and if I have a unit circle over here, let's suppose that I have some angle over here, and this angle I call it theta. Now of course this angle over here is of course 180 minus theta, and the tan of this angle, is basically this. The tan of this angle over here is basically this length. Is basically this length. This length, if I call it, for example, A, over this length, if I call it, for example, B. So I can write tan of theta is equal to A over B. Now, if I have another angle over here, you can see that so basically the other angle that I have over here is 180 degrees. So this angle over here, in the case of this angle, basically you have you have basically the sine of the angle has the same value, but the cos of the angle has a negative value, but essentially the same, meaning that you can write tan of 180 degrees minus theta is of course equal to the same. Of course the sign doesn't change, so you can write a, and the cos is a negative value now, because it is a negative value, so I have to write it as negative b, so that's negative a tan over b, which is equal to negative of basically tan of theta. So then based on this you can write tan of 180 degrees minus theta is equal to negative tan of theta. So based on this, of course you can calculate the tan of this angle over here, which is ultimately the slope of this line. So how can we do that? So the way that we can do that is that basically tan of 180 degrees minus theta, which is equal to tan of omega, which is equal to tan of omega, which is equal to m, is equal to negative tan of theta, based on what we said. Is equal to negative tan of theta, and is equal to negative 9 divided by 2. Negative 9 divided by 2. And so that is actually the slope of this line. So if I take the slope of this line, for example, as m1, then I can say that m1 is equal to negative 9 by 2. And problem solved. So now since I know that the slope of this line is m1, if I call the slope of this line m2, they are perpendicular. So I write m1 times m2 is equal to negative 1. That means that negative 9 halves times m2 is equal to negative 1. I can cancel these two negative signs, and so m2 is equal to 1 over 9 by 2, which is equal to 2 over 9. So the slope of this line is 2 over 9. 2 over 9. So now basically this line goes through the point negative 2 comma 9, and the slope is equal to 2 over 9. So then you can simply use the equation y minus y1 is equal to m times x minus x1, and write it as y minus 9 is equal to 2/9 x minus x plus 2, because it's a negative number. So y minus 9 is equal to 2/9 x plus 4/9, or you can say that negative 2/9 x plus y minus 9 negative 4/9 is equal to 0. And so this is equal to negative 2/9 x plus y, and negative 9 minus 4/9 is equal to 9, negative 81 minus 4, which is equal to negative 85/9. Negative 85/9. So this is negative 85/9 is equal to 0, multiplied by a 9, for example. You will get negative 2x plus 9y minus 85 is equal to 0. Multiply by negative 1, you'll get 2x minus 9y plus 85 is equal to 0. And that is the equation of your line. So I suppose question number was 14, or whatever it was. Number 15 is 2x minus 9y plus 85 is equal to 0, which is actually the equation of the line. We need to basically play with this a little bit to get it to the right basically orientation, so that you can work with it. And of course it's a it's a combination of geometry, trigonometry, and all of those things. But you have hopefully learned the geometry and the basic geometry and trigonometry well, so you can use them to solve such problems. Okay, so the next question is the length L in centimeter of a copper rod is a linear function of its Celsius temperature. So you have L and C, L in basically in centimeters, and this is a linear function of the temperature C, basically in degrees basically in Celsius temperature of that copper rod. So in an experiment, if L is equal to 124.942, when C is equal to 20, and L is equal to 134 when C is equal to 110, express L in terms of C. You want to express L in terms of C. Okay, so basically it is this situation over here. Since L is a linear function of C, you can regard this as basically a simple basically straight line, and these 2 points, basically this point over here, and this point over here, these are basically two points on the line, meaning that, for example, x1 y1 and x2 y2 and x2 y2 on this line, and there is a linear relationship between x1 y1, x2 y2, and so on and so forth. So now, in order to find out that linear relationship, or basically, in other words, to express L in terms of C, what you need to do is that you can think of these points as for example 20, 124.942, and another point is basically would be 110, 125.134, and you can think of this as, for example, of course, here these basically these numbers are your C's and these are your L's, but you can basically plot these points along the horizontal axis, which is normally the x-axis, and then you can plot these points along the vertical axis, which is normally the y-axis. So now if you had basically 2 points, for example x1, y1 and x2, y2, and basically on a line, and if you were to basically find the equation of that line, you would of course use y minus y1 is equal to m times x minus x1, and of course your m would be equal to y2 minus y1 over x2 minus x1. So you would basically do this simple thing in order to find the equation of that line. And you can do the same thing over here, meaning that you can basically thinking of these two as of course as 2 points on the line. You can write your m is equal to, for example, 125.134 minus 124.942 and over 110 minus 20. Now this over here is 125.134 minus 124.442. 442, that's a 2. And then you have, this is a 4, 11, 10, 13, 13, so 9, 6, 0, 0, 0. So over here in the numerator you will get 0.692. Denominator you will get basically 110 minus 20 is equal to 90. Is equal to 90. And so that is of course you might be able to basically simplify this ratio, which is let me see, 692. If you divide this by 2 you will get 390 is 45 and 2 is 1, so that's basically a 6 for 346. And so that would be basically 0.346, and this would be 45. Now 45 is divisible by 3, by 9, by 5. This is not divisible by 5, but probably by 2, 3, and 9, of course. So 6 plus 4 is equal to 10 and 13. So this is not divisible by 3. I don't think there is any way to simplify this any further. I don't really think so. 0.346 divided by 45 is equal to 173. Well, it has, the calculator has basically multiplied the numerator and denominator, I think, by a factor of 1,000. And then, but let's keep it as it is. We don't really need to do anything to this. So we can write this as 0.346 divided by 45. That is the slope of the line. And then you can write y minus y1 is equal to m times x minus x1. So then you can, for example, pick this line as this point as x1, y1, and write y minus basically 124.942 is equal to m, which is 0.346 divided by 45 times x minus 20. X minus 20. So y minus 124.942 is equal to 0.346 by 45x minus 20 times this is equal to 0.346 by 45 times 20. Divide by 5 is equal to 4. Divide by 5 is equal to 9. And, well, 4 times 13. So 346 times 4 is equal to 4 times 6 is equal to 24, 2, 16, 18, 1, 12, 13. So that's 1.384 divided by 9. So that's 12. 12 plus 4 is equal to 16, not divisible by 3. So that's the same thing as That is the same thing as 1.384 divided by 9. And that is basically your equation. And of course, you can of course, instead of, for example, y, you can write, for example, L instead of x, you can write C, meaning that you can write L minus 124.942 is equal to 0.346 divided by 45 times C minus 1.384 divided by 9. And then you can write, basically, since you want to find everything in terms of L, then I can write L is equal to 0.346 divided by 45 times C minus 1.384 divided by 9 plus 124.942. And then if you do this part over here, you will get, oh, it's a lot of trouble really. So negative 1.384 divided by 9 plus 124.942 is equal to 9 times 124.942 times 9 is equal to 18.1, 36, 37, 3, 81, 84, 8. 36 plus 8 is equal to 44, 4. 18 plus 4 is equal to 22, 2. 9 and 2 is equal to 11, and 3 decimal places. It's equal to, so here you have negative 1.384 plus 1124.478, and so you can write this as, we can write 1124.478 minus 1.384, and that's a 4, 3, 17, 9, 0.3211. So that's the same thing as 1123.094 divided by 9. And this is 13. 5 plus 2 is equal to 7. 7 plus 13 is equal to 20. You cannot simplify it any further. So you can write this as plus basically 1123.094 divided by 9. And here you can write 0.346 divided by 45 times C, which is equal to L. And that is basically some relationship between L and C. If you get to the answer, number 16, 192. I'm not really sure if the numbers are a little bit weird here, and the answer doesn't seem to be right. But that's basically how you would solve this kind of example. I don't really want to go back and check my numbers. We will. Let's move on to the next example. This was not a very good example. Okay. So the next question is, the owner of a milk store finds that he can sell 980 liters of milk each week at 14 rupees per liter, you can sell 980 liters of milk each week. So basically each week at 14 rupees per liter, at 14 rupees per liter, let's take this as capital L, and 1220 liters of milk, 1220 liters of milk each week at 16 rupees per liter, at 16 rupees per liter. Doesn't make any sense, because now that you have increased the price you pay, you can sell more. Assuming a linear relationship between selling price and demand, how many liters could he sell weekly at 17 rupees per liter? So you want to know how many how many liters could he sell at 17 rupees per liter, at 17 rupees per liter. So you see, this is a little bit, I mean, it doesn't make any sense really. 17, yeah, it does not make any sense, because as you're increasing your price, the demand is increasing, which is usually not like that between people. I mean, between logical people, they usually don't behave like that. But it doesn't really matter. Now, the way that you can again find some relationship between L and the price, take it P for example. So you can basically, what you can do is that basically first take these as 2 points, for example, 980, 14, and take this as another point, 1220, 16. And based on this, I will calculate some slope. So M is equal to basically, or I take this as the output. So I'm going to write this as, I'm going to take this as 14, 980, and I'm going to write this as 16, 1220, and then I can write 1220 minus 980. But in this examples, the numbers are, well, okay. 16 minus 14, so 1220 minus 980 is equal to 0, and 0, 12, 11, 12, 4, and 2, 240. This is 240 over 2, which is equal to 120. So the slope is 2. And there might be some constant as well here. We will find out. So you know that y minus y1 is equal to m times x minus x1. So I can use, for example, this point and write y minus 980 is equal to 120 times x minus 14. So y minus 980 is equal to 120x minus 120 times 14 is equal to 28, 14, 8610. So minus 1680. And that's the constant that I was talking about. So your y, basically the output over here, is equal to 120x, and you have negative 1680. So if you write 1680 minus 980, you will get 0, 0, and this is 16, so 16 minus 10 is equal to 7, 700. That's minus 700. Because you have negative 1680 plus 980, you get negative 700. And then of course you can write this as L standing for liters of milk, and you can substitute P here for X, for basically for price, for example. L is equal to 120 P minus 700. And of course you can test this, meaning that, for example, if the price is 16 rupees per liter, if P is equal to 16, then L is supposed to be 1220. So L is equal to 120 P times 16 plus minus 700, which is equal to basically 16 times 12, 32, 16, 192, 0, and if you subtract 700 from this, you'll get 1220. This is equal to 1220, which is basically the right answer. Now, what that means that basically the relationship is actually correct. Now, we wanted to know what is going to be your L. I mean, how much milk you can sell if the price goes up to 17 rupees per liter. So that means that when P is equal to 17, then what is L? So your L is equal to 120 times 17 minus 700, and that is 17 times 12, and a 0 over there, so you have 14, 1, 34, 0, 17, 4, 0, and 2, 0. And if you subtract a 700 from 2040, you will get 1340. You'll get 1340 liters of milk. And is equal to 1340, which is number 17, which is the correct answer. Now there is another question here, number 18. Number 18, it says that P, A, and A, B is the midpoint of a line segment between axes. P, A, B is the midpoint of a line segment between axes. I don't understand what is between axes. Okay, so the next question that we have here is a question that is a little bit, I couldn't understand the question first, and then I had to take a look at the solution to understand the question. So it says that P with coordinates A, B is the midpoint of a line segment, midpoint of a line segment between axes, and I will tell you what that means. show that the equation of the line equation of the line is basically x divided by a plus y divided by b is equal to 2. I want to show that the equation of the line is this. Now what this means is that the line segment, you have a line segment over here, and between axes means that you have an xy plane, and well, at least based on the solution that I can see here, what is meant here by between axes is meant that the line segment is some line segment, for example, something like this, and well, P A comma B is the midpoint of this line segment, and you can call this, for example, AB, and this is the y-axis, this is the x-axis, and this is O, for example. So now basically the way that you can solve this problem is that basically you know that basically this point is the midpoint of these 2 points. So then you can say that the midpoint formula, we said that the coordinates of this point, meaning that the coordinates of this point a comma b is the same as basically the coordinates of these 2 points, meaning that for example you could say that the coordinates of this point is something like, for example, 0 comma y, and the coordinates of this point you can say that it's something like, for example, x comma 0. Now if that's the case, now the coordinates of this point P is going to be basically 0 plus the x coordinate of it is going to be 0 plus x divided by 2, and the y coordinate is going to be 0 plus y divided by 2. And so a comma b is the same as x divided by 2 and y divided by 2. So what that means is that a is equal to x divided by 2 and b is equal to y divided by 2. So, and well, over here x is equal to 2a and y is equal to 2b. Now the coordinates of these points, the coordinates of these points a and b become basically, a would be basically 0 comma 2b, and the coordinate of the point b would be x, which is equal to 2a comma 0. And now all you need to do is basically find the equation of the line going through these 2 points. So the line going through these 2 points is basically y minus y1 is equal to y2 minus y1 over x2 minus x1 times x minus x1. So you can write this as basically I take this as y x1 y1, so y minus 2b is equal to y2 minus y1, so that's 0 minus 2b, and x2 minus x1 is 2a minus 0 times x minus 0. and y minus 2b is equal to negative 2b over 2a times x, and 2 and 2 can cancel out. So that means that y is equal to basically, or I can write it this way. Let me write it this way. I can write this as y and take this to the other side, plus b by a times x is equal to, take this to the other side, that becomes 2b. Now if I multiply this equation by a, I will get ay plus bx is equal to 2 times ab, and if you divide the whole equation by ab, you will get ay divided by ab plus bx divided by ab is equal to 2ab divided by ab, and so a and a cancel out. Y divided by b plus x divided by a is equal to basically 2, and that's basically what we wanted to show here. Okay, so the next example is basically point R with coordinates h comma k divides a line segment. So this is a point R, h comma k divides a line segment between the axes in the ratio 1 to 2. Find the equation of the line. So this divides a line segment between the axes in the ratio 1 to 2. And now you want to find the equation of the line. Okay, so the next question that we have is another question that says basically point R, there's a point R with coordinates h comma k that divides okay, so that this point basically divides a line segment. It divides the line segment, divides a line segment between the axes, and I suppose you know what that means, a line segment between the axes, and we are going to draw a diagram in the ratio 1 to 2. In the ratio 1 to 2, you want to find the equation of the line. So basically what we have here, based on what they mean between the axes, a line segment between the axes, you can imagine that you have some line segment over here, and there is a point on this line, for example R over here, with coordinates h comma k, that divides this line segment internally in the ratio 1 to 2. And basically we said that the that the coordinates of the point dividing the line segment joining the points x1 comma y1 and x2 comma y2 internally in the ratio m to n is given by m plus it's given by m times x2 plus n times x1 over m plus n, and m times y2 plus n times y1 over m plus n. So that means that if you have this point over here r with coordinate h comma k that divides this line segment in the ratio, basically in this case 1 to 2, and suppose that we have this point over here, call it a for example, with coordinates basically 0, the x coordinate here is 0 comma y, and the x coordinate and the coordinate of this point b for example over here is x comma 0. The coordinates of this point is going to be the coordinates of the point r, which is of course equal to h comma k. H comma k is equal to basically m times x2. Let me make sure I haven't written this wrong. So it is m times x2 plus n times x1 m plus n, m times y2 plus n times y1. Okay, so over here you have basically m times x2, so your m and n, m to n over here is equal to basically 1 to 2. So your m is 1, n is equal to 2. Your m is 1 and x2 is equal to, take this as x1, x2, take this as x1, take this as basically x1, y1, and take this as x2, y2. So that would be basically m times x2, which is equal to x, plus n times x1, which is equal to 0, and you want to divide that by m plus n, which is 1 plus 2, which is equal to 3, and the x coordinate of this point is m times y2, so that's 1 times y2, which is equal to 0, plus n times y1, so 2 times y1, which is equal to y, divided by 3. And so what we have over here is basically h comma k. H comma k is equal to basically x over, or 1/3 x, and over here you have 2y 2/3 y. So this means that h is equal to 1/3 x and k is equal to 2/3 y. So over here x, if you want to calculate x is equal to h divided by 1/3, which is equal to h times 3, which is equal to 3h. Your x is equal to 3h, and your y over here, so if k is equal to 2/3 y is equal to k over 2/3, which is equal to k times 3/2, which is equal to 3/2 k. So y is equal to 3/2 k. Now, based on this, the coordinates of these 2 points, will become basically 0, 3/2 k, and the coordinates of this point becomes basically x, which is equal to 3h, 0. So now you have basically these 2 points, 0, 3/2 k, and basically 3h, 0, and you want to find the equation of this line based on these 2 points. So you know that y minus y1 is equal to basically y2 minus y1 over x2 minus x1 times x minus x1. So basically y minus y1 is equal to 3/2 k is equal to y2 minus y1. So that's 0 minus 3/2 k over x2 minus x1. That's 3h minus 0 times x minus x1, which is equal to 0. So y minus 3/2 k is equal to negative 3/2 k over 3h times x. Now 3/2, so 3/2 divided by 3 is the same thing as 3/2 times 1/3, which is equal to 1/2. So that is, and basically there must be something wrong here. This is an h. Okay, so this is y minus 3/2 k is equal to negative 1/2 k over h times x. So, and if you move this to the other side of the equation, you will get to, let me see how they have written this. Okay, so you'll get positive 1/2 k over h times x plus y is equal to, move this to the other side, 3/2 k, and if you multiply by 2 you will get basically this will be cancelled out, so k over h times x plus 2y is equal to 3k, and multiply by h, you will get kx plus 2 times hy is equal to 3kh, and that is the equation of the line. 2k well, 2kx plus hy is equal to 3 times but this must have something to do with basically well, depending on whether you take this as depending on whether you take this point as basically, depending on whether you take this distance as 1 and this distance as 2, or you take the point down here, for example, and that would become 1 and this becomes 2, then you would get another equation. You would get another equation which would be basically 2 times kx plus hy is equal to 3 times kh. So you would, this is basically the answer that has been given in the book, and you would get, I'm pretty sure that you would get this equation if you took the point, for example, somewhere down here, and then you change this ratio to 2 to 1, for example. But as long as you take, you basically take the ratio this way, meaning that you have to basically, you have to call one of these m and you have to call one of these n, and that depends on you, depending on what you want to do, depending on the specific situation. Then you take one of these as m and you take one of these as n, and then and then of course the coordinates of this point is going to change. So that depends on that. So and there is another question over here. There is also question number 20. It says that by using the concept of equation of a line, prove that the 3 points are collinear. So if you want to prove that 3, 0 and -2, -2 and 8, 2, you want to prove these points are collinear. So what you can, I think that basically based on the concept of equation of a line, what you can do is that you can basically derive the equation of a line based on these 2 points, and then derive the equation of another line based on these 2 points, and then you will, if the 3 points are collinear, you will basically get the same equation in both the cases, and then that means that the 3 points are collinear. But otherwise I might be wrong. So over here we have, in order to show that points are collinear, it suffices to show that the line passing through these 2 points also passes through that point. Passing through this point is basically this. Okay, so you can, well, of course, this is also, acceptable and easier, meaning that, for example, you can use these 2 points and write y minus y1 is equal to m times x minus x1, and then the slope of these 2 points would be basically -2 minus 0 and -2 minus 3, which is equal to -2, -5, which is equal to 2/5. And so you could write y minus, for example, 0 is equal to 2/5 times x minus 3. And then you could write y is equal to 2/5 x minus 6/5. So this is the equation of the line passing through these 2 points. Now if these 2 points satisfy this equation, That means that okay, so now if this point satisfies this equation, that means that then the three lines are collinear. So over here, if the point 8, 2, you will get basically 2 is equal to 2/5 times 8 minus 6/5. So 2 is equal to basically 16/5 minus 6/5. 2 is equal to basically 10/5. So 2 is equal to 2. And that proves that the three lines are collinear. Okay, so we are done with these exercises. The next thing that we have in this chapter is basically some concepts related to general equation of a line and that sort of thing. And I will try to do a short tutorial on that, some basically brief explanation, and then after that we have some exercises related to that. So I'll see you in the next video. Thank you.